Okay, so for 6, I wanted to do another example that you may see. And if you do have a coefficient in front. So we want to first, when you're using this variation of parameters, first put in standard form. So I'm going to get y double prime plus 9y equals 1/4 cosecant 3x. Okay, so when we do these problems here, right, the first step is to find y1 and y2. So I want to, basically I'm finding y sub c, right? So I have m squared plus 9 equals 0. And just to go over this real quick from algebra 2, right, remember you're going to take the square root of that -9, giving us 3i, right? So here it's really 0 plus, sorry, I forgot the plus minus 3i, so our alpha is going to be 0 and our beta is going to be 3. So really what you get, y of c is going to be e to the 0x. That's going to wind up being 1. Then you have that c1 cosine 3x plus c2 sine 3x. Okay. So what I'm going to do is just rewrite it as c1 cosine 3x plus c2 sine 3x. Okay. So here y1 is 3 cosine 3x, and y2 is going to be sine 3x. Alright, so we have that set up. Remember, you're going to use this at the very end anyway, but the main thing is we want to find what y1 and y2 are. Okay, so now let's do w, right? So w is going to equal, you have cosine 3x, the derivative would be -3 sine 3x. Here we have sine 3x, derivative of that is 3 cosine 3x, right? So remember, you're multiplying, so we get 3 cosine squared 3x, subtracting and multiplying, which is going to make that a plus 3 sine squared 3x. Now this is just equal to 3, right? Because cosine squared of an angle plus sine squared of that same angle, right, we know is 1. So we get w to be 3. Okay, so that's nice. Okay, w sub 1, remember you're putting zeros here, and then you put your function, so that's 1/4 cosecant 3x, and then you have your y2 sine 3x, and the derivative of y2, 3 cosine 3x. Just remember, right, if you do that first, right, it's 0 minus, and then we would get a 1/4 of cosecant 3x times sine 3x. But that just simplifies down to -1/4, because remember, these two are reciprocals of each other, so that becomes a 1. So now we have w sub 1 to be that negative, I just don't want to have this highlighted, okay, but I do want to have this highlighted here. So we get that -1/4 for w sub 1, and then w sub 2 done pretty much the same way. Okay, we'll have cosine 3x at -3 sine 3x, 0, and our 1/4 cosecant 3x. So we wind up getting 1/4 cosine 3x cosecant 3x, but that's really 1 over sine, so we get 1/4 of a cotangent 3x. Okay, so let's do u1 prime, right? Remember, is w sub 1 over w, so we get -1/4 over 3, which is -1/12. U sub 2 prime is going to be w sub 2 over w, and in this one we have the 1/4 cotangent 3x over 3, which is going to give me 1/12 cotangent 3x. Okay, So now u, right, so you're going here, you do your antiderivative. So u sub 1, this one's an easy one, 1/12 x. U sub 2, right? So just be careful of this 3, right? So I'm going to divide by that 3 or multiply by 1/3. And that's going to give me 1/36. Now your anti of cotangent, right? Anti of a cotangent, if you rewrite it as cosine over sine, sine would be your u. You're going to wind up with 1 over here. So it's ln of sine 3x. Okay. So now we could put everything together to get our particular solution here. Remember, it's u sub 1, y sub 1, plus u sub 2, y sub 2. So I'm going to have a negative 1/12 x times cosine 3x. And then I'm going to have too many text messages. 1/36 ln sine 3x times a sine 3x. Okay, so let's put everything together now. So I'm going to put my y sub c together and the y sub p together, and then that would be our final solution. Okay, so I would wind up with y equal to c1 cosine 3x plus c2 sine 3x minus 1/12 x cosine 3x plus 1/36. I'm just going to put the sine 3x first, and then ln sine 3x, just like that. And that would be your final solution to this differential. Okay, and so that should help you with 4-6. So hopefully those